Hi, welcome to working with the least common multiple. We're going to find the least common multiple for 16 and 20. Well, before we do that, I think it's really important to understand why you would use or need the least common multiple. Let's say that you had the fraction 1/16 and you had 1/20 and you wanted to add these. Well, you would need to find a common denominator. So the least common multiple can be used for finding a common denominator and also comparing fractions when you need to find a common denominator. So let's look at how this works. We're going to go back to factor trees. So I'm going to do a factor tree on 16 and also the number 20. So when I think of 16, I think of 4 times 4. I'm going to factor these into their primes. I like to circle the numbers once they're primed so I know that I'm done. And then this one would be 4 times 5. And then I'm going to factor 4. Okay, now under the 16, I'm going to write 2 times 2 times 2 times 2. Those are the primes. And then under 20, I'm going to write 2 times 2 times 5. Now, this is very different from the greatest common factor. So what we want to do is we want to look at 16 and we want to look at 20. We want to take the one that has the most 2's. Well, which one has the most 2's? Is it 16 or 20? Well, 16 does. So we're going to take all of these 2's. So that would be 2 times 2 times 2 times 2. Now I have to look at my other prime numbers, and there's a 5. Well, 16 doesn't have a 5, but I have to take the 5, so I'm going to take it from the 20. And now, if I multiply these numbers, then I'm going to find the least common multiple. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So this equals 16. And then times 5, and that would be 80. So the least common multiple for these two numbers would be 80. So again, if I was going to add 1/16 plus 1/20, I would have to change the denominators to an 80 in order to add them. All right, let's take a look at one more. 15 and 12. So we're going to factor them into their primes. So the primes for 15 are 3 and 5, and the primes for 12 in numerical order are 2 times 2 times 3. We're going to start with the smallest prime number. Which one has the most 2's? Well, they're right here. So I'm going to take both of those. Which one has the most 3's? Well, they both have a 3. So I'm just going to take one of them. Which one has the most 5's? Well, this one has the 5, so I'm going to take that. We didn't use that 3, so we're done. So if I multiply these numbers, I'm going to come up with the least common multiple. 2 times 2 is 4, and 4 times 3 is 12, and 12 times 5 is 60. So if I needed to add, or let's say that I wanted to compare, maybe we had 11/15, and say we had 7/12, and I wanted to compare these two fractions. I could easily turn the denominators into a 60. So let's go ahead and do that. We already know that this one is bigger. I mean, I think it's sort of obvious, but just in case we don't, you can compare fractions by coming up with a common denominator. So we said 12 times 5 was 60. So then I multiply the top number by 5 and I get 35. And 15 times 4 is 60. Now, since we have the same denominators, we can easily see that this numerator, 44, is larger than 35. So this would be our largest fraction if we had to compare fractions. So this is working with the least common multiple, and thank you for visiting my video, and check out my others online.